Stanford University.
So welcome to lecture, I don't even know, I said this last time too, I think we're, I don't know, halfway through the quarter. It's odd, so it must be 11 or so. Today, I'm going to actually spend a few slides reviewing, since we're halfway through the quarter, just putting a big long list of things that we've learned so far, which is quite a long list. I mostly put these up here not because I'm going to go through them all again, but I just want you to have these on a slide that you can refer to later and read through and convince yourself, yeah, I know that. Now, if you've done all the homeworks, all the required items, then you certainly should know all these things. But if you maybe struggle with the homeworks or whatever, this might be a good list of things to consider to review yourself. So the first thing is Objective-C. We've learned an awful lot of Objective-C, a new language. We've learned about classes and methods and properties and protocols, all that stuff. So you should feel pretty comfortable right now with Objective-C. Okay, you've written hopefully a lot of Objective-C code. You're comfortable with that. And along with that foundation, which we kind of almost think of as part of the language, things like arrays and dictionaries. So you should be very familiar with strings and all that stuff and foundation. Probably one of the most important things that you need to start feeling comfortable with is MVC. Okay, we started off the very first lecture, the very first day with MVC, and I've had you build a lot of different MVCs as part of your homeworks, and sometimes you probably did it right, picked a good model and controller separation, view controller separation. Sometimes you probably like, oh, that was not quite right. And hopefully you learn from those experiences as well. But MVC, really one of the most important conceptual things to get in this class. And then, of course, UI view controller, which is the C in your MVC when you're programming in iOS. It's important to know about that. Its view property, how that works, load view, zip files, all the life cycle methods, etc. So you should really start to feel comfortable with that. Interface builder, you should feel pretty comfortable in there, dragging things out, setting attributes, how to do a custom view by dragging out a generic view and then going to the inspector and editing the class, things like that. Let's see, what else we got? Custom views, doing your own draw rect, you should feel comfortable doing that. Gesture recognizers. The application lifecycle, which is which mostly we're just do application did finish launching with options. That's our main application lifecycle thing that we've done in this class. We will talk a little bit about things like application will terminate and what happens when you're multitasking, you get put in the background. We'll talk about that later in the quarter, but you should certainly be comfortable with the multi-platform aspect of building an application and having conditional code throughout your app, but especially in application did finish launching with options to build your split views versus your navigation controllers, etc. Speaking of which, you should be familiar and comfortable with UI navigation controller. We used it in almost every app since it was introduced, and we'll continue to use it in every app the rest of the quarter that you're going to build. Not just the pushing, but setting up the view controller to be pushed so that the view controller that gets pushed kind of can run independently. Also, we didn't talk a lot about this property navigation item in UI view controller. We've mentioned it briefly in some slides, but that's something you might want to go look at and familiarize yourself with what's in there. That's how we put the bar button up, for example, in the split view controller, things like that. Navigation item is just an object that collects all the look for your view controllers when it's on screen inside a navigation controller. Okay. And controllers of controllers in general, tab bars, split views, popovers. We've done the actual controllers of controllers, tab bar, split views, and navigation controllers in assignments. We haven't really done a popover controller except for the little delegate thing for split view that puts up a button with popover controller, but you don't have to actually write the code there. That's not something that will be in an assignment, so that might be something if you want to have some time to do some stuff on your own. I know you're all pretty busy students, but popover controller is another one to try and be familiar with. And then scroll view and image view and web view, which you're in the throes of doing right now. And then table view, which you're also in the throes of doing right now. We just covered that last time, so I'm not going to go over this, but you should be starting to feel pretty comfortable with table views. It'll be intense table view activity in the next assignment. Okay. And actually what I'm going to talk about today has a real strong integration with table views. So if you're kind of dicey on how this table view thing works, then you're going to get a little dicier when I start talking about how we load up a table view with data from a real database, like a SQL database or something like that. That's what we're going to talk about on Thursday, but I'm going to talk about the database part today. So that's another big one to know. Also, table views are just in the vast majority of iOS apps. So this is a good one to really feel comfortable with. All right? And I don't expect you to know the full breadth and depth of table view. It's a very massive system, but certainly getting a table view set up, loading up its data, etc. You should start feeling like you know how to do that. Okay, so that's all I had on review. So today's topic is persistence. And I don't mean persistence like what you have to do to get these homeworks done to be persistent. I mean persistence like making data that's in your application stay around, okay, between application launches. And we've seen a little teeny bit of persistence with NS user defaults, but that's just almost like a toy. That's preferences or settings kind of persistence. So today I'm going to talk about different mechanisms. We will cover a little bit more on property lists, making them persistent. I'm going to talk about archiving objects, which is a way to make large object graphs that aren't property lists. In other words, have things in them besides dictionaries, arrays, etc. How to make them persist. I'm going to talk about storing things in the file system, right? You might store images or sounds or videos in the file system, so you need to know how to do that. I'm going to have one slide and briefly whiz by SQLite, which is if you want to actually write SQL directly. SQL is a database query language. You can do that. But then we're going to spend most of our time talking about core data. And core data is the object-oriented way to store data in a database, okay, on iOS. Very important concept to really understand. I'm going to spend all of, pretty much most of today after I cover these other topics briefly, and most of Thursday before I do a big demo about it, talking about core data, okay, especially its interaction with table views. Okay, so that's what we got for today. So let's go to property lists. You already know that property lists are any combination of arrays, dictionaries, strings, dates, datas, and numbers. And you also know that it's really only good for small amounts of data. Okay, you're not going to store massive images in there. You don't want to store, like in your current homework, you wouldn't want to store all their places and stuff like that in there on a regular basis. It's just not for huge amounts of data. Okay, and it can't be queried. You can only just load things up and start looking through keys and dictionaries. So it's very, very limited in that sense. However, it can be stored permanently. If you have a property list structure, there are a number of ways to store it permanently. You already know about NS user defaults, which is one way to store a property list permanently. And there's also three formats that a property list can be written out to. One is XML, one is a binary format, okay, it's a non-human readable format, and then it's got this old style ASCII deprecated format. That's what I showed you in the last demo where we saw the dictionary of the words divided into their letters, A, B, C, D. So that's really an old style. That's mostly for demos and stuff like that. Really, XML is kind of the new style. That's what most people use, but the binary style might be used for large property lists that have big NS datas in them, for example, things like that. So how do you serialize a property list? How do you make it, put it in a file or something like that? And the answer is you use this class NS property list serialization. It only has class methods. You don't create an instance of an NS property list serialization. And the two main class methods I'm going to talk about, one takes a property list and throws it into an NS data. You'll remember that an NS data is just like a bag of bits, right, unstructured data in there. And the other one takes an NS data and sucks a property list out of it. Okay, so that's the two methods. So this one is the one that throws the property list into an NS data. You can see it's a class method. It just takes an argument, which is a property list. And the format, which is either XML or binary, because we're creating them here, so it doesn't even allow you to create the old style ones with this method. And then it's got these options, which are not used, so you set that to 0. And then it's got this error colon. And actually, I'm going to take a second and talk about this error colon, NS error, star error. I'm sure I've presented some API that has this already, but I haven't really taken time to talk about it. An NS error object is just an object. It's got a few methods on it, like give me a string that describes what the problem was. and give me an object which is the user info from this method when it's reporting this error of what went wrong that's specific to this method. And a lot of methods in the iOS that can return an error, most of them, and it should be all of them, it's getting to be the point where it's almost all of them, should be doing it this way, where they have this method argument, it's the last one usually, and it's an NS error star star. So it's a pointer to an NS error. So the way you call it is you create a local variable, NS error star error equals nil. You usually set it to nil. And then you call, when you include it on the line here, you say ampersand error, which means a pointer to this variable. Okay? So hopefully you guys mostly know C. You're used to that ampersand syntax. It just means give me a pointer to this thing. And then if there's an error, it will fill, it'll fill that pointer to an object with a pointer to the NS error that happened. And if there's no error, then it's not going to happen. Now the nice thing about this is you can just pass null here. Okay, not nil, because this is not a pointer to an object. It's a pointer to an object. So you could pass null, which is 0 also. And that just means I'm not interested in the errors. Okay? And in this case, for example, if you pass null and there was an error, it's just the NS data that was returned would be nil. Right? So you'd get a nil data back. You tried to turn your property list into a data and there was an error, like maybe one of the things in there wasn't a property list, and it just returned nil. So this is a common paradigm. You're going to see a lot of methods today that do that, take this error at the end, and you can ignore it by pressing null, but you kind of ignore it at your peril. And usually the return value of whatever you're calling is going to be your only indication of error if you don't do that. A lot of times, kind of what's good programming practice here, you don't always want to be in a situation where you're poking in that NS error and trying to figure out what exactly went wrong. Sometimes you really care. A lot of times you just want to log it. So a lot of times you'll see people create an NS error, and then on the next line after they call this method, they'll just say NS log, if error, then NS log percent at sign, which means a string. And then the argument they'll put is error localized description, which is a description of the error, supposed to be in a somewhat user-readable format, localized to your local language even. That's a common one to want to print out in your console. Okay, so then if it fails, you'll know. Question?
Can you explain when to use null and when to use nil again?
Yeah, so the question is when to use null, N-U-L-L, all caps usually, versus nil. What's the difference? Well, they're both just type deft to 0. Okay, they both mean 0. But nil means semantically in the code a null or 0 pointer that is an object pointer. Whereas null means a C pointer. Okay? So like if you had a char star and you were setting it to being a null value, you would set it to null, not nil. But if you had a UI view controller star, then you would send it to nil. So it's mostly a code readability thing. Just when you see nil, it means this is a pointer to an object, which is 0. And if you see null, it means it's a pointer to something else. And in this case, it's null because it's a pointer to an object. It's not the actual pointer to the object, it's a pointer to the pointer to the object. That's why it's null. Okay, so that's that way. This is the opposite way. So you've got an NS data that someone created using the first method, and now you want to turn it back into a property list, and you can see it just takes the property list. This one does have some options, which I'm going to talk about in a second. And notice that the format here is a NS property list format star. So it returns the format. Okay, NS property list format is not an object. It's just a type def. And so the star there means it returns it. The first one you notice doesn't return. It actually takes the format. And this one returns you back what format it found in that NS data. The options that you can do with this one have to do with mutability. So here, remember, you're creating a property list from NS data. You can have the property list read option immutable, and then all the stuff that'll come out of there will be immutable. Immutable NS dictionaries, immutable NS arrays, immutable strings. Or you can do NS property list mutable containers. Then your containers, your NS arrays and NS dictionaries, will be mutable. But the leaves, like NS strings or NS datas, will be immutable. Okay? And then there's also property list mutable containers and leaves. Everything will be mutable in there. Very rare to use that, almost never. Make sense? What's going on there? So you can actually make a deep mutable copy using this. You can imagine, right? You had an immutable property list, you put it in an NS data, and then you pull it back out saying mutable containers, and it'll make all the containers in there mutable. So it's a way to kind of do a mutable deep copy. Okay, so now you have this property list, and you can turn it into an NS data, but usually you actually want to write it to a file or something, because an NS data is not doing you much good. You got this NS data bag of bits with the property list in. So you're probably going to call something like NS data's write to file, okay, or write to URL, which is really kind of the preferred way to do it. So you create an NS URL, which is a file URL. It's the only kind that's currently supported to write an NS data to. You can't write it out some internet. There's no way to specify some place to write it besides a file. And you can see that it returns a bool, which is whether or not it's succeeded. And it also takes this argument, which is a bool, which is atomically. And atomically just means it's going to write the file to the file system in a temporary file. And once it's successfully written and closed that file, then it's going to remove the thing you're actually writing to, if it exists, and rename the new thing. So that you'll never get a partially created file, right? So if you have a file that's sitting there and you write atomically, the one that's there will not get corrupted. It'll either, be replaced in its entirety by a new one, or it'll be left there if, like, the phone dies in the middle of the operation or something like that. So that's what atomically means. And then the other way around as well. You can alloc and init an NS data from a file by saying init with contents of URL. This one actually you could specify http:/something. It'd be unlikely that you would be reading NS datas off of an HTTP server. You might be reading NS dictionaries like I did in the demo, but it's unlikely you would be reading an NS data that has a property list in it. And in fact, it's more likely if you're going to read some kind of dictionary and array data that you're going to read it in an industry standard format like JSON. And so let's talk about two file formats. First, I want to take a brief look at what a property looks like in XML format, and then I'm going to show you a JSON format file, and then I'll talk a little bit about conversion. So here is what the XML file format looks like, and it's exactly what you would expect. It describes what a certain node is in the property list, like a dictionary node or an array node, and then for a dictionary node, it tells you the key and the value. For an array, it tells you the type of each thing, whether it's a real, which would be an NS number, or whether it's a string or another array inside it, whatever. So this is what an XML thing. It's, quote, human readable in that it's, ASCII text, but parsing this, certainly I don't expect you to be able to parse this very easily anyway. All right, next topic, archiving. So sometimes you have very complicated object graphs that aren't property lists, and you want to store them and then reconstitute them later. Okay, so the iOS has a mechanism for working with these arbitrary graphs, and a good example of an arbitrary view graph is the view hierarchy you build in Interface Builder, right? So you're dragging out all these things in Interface Builder, you're setting all their properties and things like that, and when you hit save in Interface Builder, what does it write out? Well, the answer is it archives the objects. Okay, and so we're going to talk about what that mechanism is. It's pretty simple, fundamental mechanism, but you have to be really careful how you implement it. Okay, if you're going to implement an object that can be written out in an archive, you really got to think about how you're going to do it, and you'll see why as this unfolds. The main thing is there's this protocol called NS coding. Okay, all objects that want to live in a view hierarchy or any object graph that's going to be archived need to implement these two methods in the NS coding protocol. Okay, there's only two methods. The first one is, we'll do them one at a time. The first one's called encode with coder, and this is going to give you this coder object, and it has a bunch of methods on it that you can use to store, essentially, to encode your object's state. Now, when you encode these things, they don't have to correspond to instance variables. Usually they do, but they don't have to. And you can encode them in any order that you want. And you can see that for each one that you encode, you give it a key. So this, you could imagine, might be the encoding of a graph view, right? And so here it's encoding the scale as a float, encoding the origin as a CG point, and it's encoding its expression that it's displaying. So maybe this is some kind of graph view that has an expression in it, and it's encoding that as an object. So you can see that the coder has a bunch of methods: encode this, encode that, etc. So you encode all that. And I note here, absolutely positively, you must call supers in code, otherwise your supers instance variables would not get encoded. So this will get called by the coder, the thing that's archiving your objects. And then when it's time for your objects to get pulled back in, unarchived, it's just alloc init with coder. Okay? So your designated initializer, notice, does not get called when you get loaded from an archive. That's why we have await from nib, right? Because the things you build in Interface Builder that you load back up when your zip file is loaded, they're getting called alloc init with coder, not alloc init with frame or any alloc init with nib name bundle. They're getting alloc init with coder. You see why now we have to have await with nib? Because our designated initializer doesn't get called for any of our objects. They get archived and then unarchived. So here you can see I'm unarchiving the thing I coded above, and notice that it's in different order. I pulled out the expression before I pulled out the origin, but it doesn't matter because it's all by key. Okay? Notice also I had to retain the object. So when I decode an object, it comes back auto-released. So if I want to keep it, I have to retain it. And this is where the rub comes in of why this is not so easy to implement as it might seem, because you're talking about archiving an entire object graph here, and that's going to have objects pointing to each other. And you've got to make sure this thing comes out of that file with the right retain count for everything, right? So that everything that points to something else, you're not constantly retaining it a billion times. You've got to know who is responsible in their init with coder for retaining whom. And also you've got to make sure you know where to stop, okay? For example, what if you're doing a view hierarchy? Do you archive your super view or only yourself and all your subviews? Well, probably you don't do your super view, but if you're in the object graph, then you do want your super view hooked up. Do you see how it starts to get a little complicated? So you have a simple mechanism here, but you have to know what you're doing. And I do not think that for this class and for your final projects, you want to get into archiving, because it can really, if you're archiving something fairly straightforward, you might want to convert it to a property list or use core data. And if you're doing something that's really complicated object graph, then you're going to run into the boundary conditions of coding. So anyway, once you have this coding and decoding set up, then the way you save in a hierarchy and return a hierarchy object graph, I keep saying hierarchy, but I really mean object graph, is using these two classes, NSKeyedArchiver and NSKeyedUnarchiver. And you can see how they work. You just send them the class method archive data with root object. You give it an object that implements NSCoder, and everything in that object graph has to implement NSCoder. And it will return you a bag of bits with all that stuff encoded. And then to get it back, you just send a class method where you pass it the bag of bits, and it'll return you back a entire object graph. Okay? So if you think you understood that, what do you think this code does, right? We have an object. It implements NSCoder. We say keyed archiver, give me the archived data with root object. And then I say ID NSCoder dupe equals NSKeyed archiver unarchived object with data. And the answer is that it makes a deep copy of that first object. Okay, because it archives the entire object graph starting at that object, and then it unarchives out of the NS data a whole other copy of it. So some people have said, wow, I could use this to like copy a UI label. And the answer is, yeah, you could. And in some cases, that might be an okay thing to do. Maybe you'll set up a UI label, and you want to copy it 20 times because you're going to have 20 UI labels exactly the same. You could use archiving to do that. Okay? You'd want to be a little bit careful about what view hierarchy it's in, things like that, but generally that kind of works. But this is advanced topic archiving. All right, so file system. Back to down to earth here of things that you're definitely going to do in this class, is work with the file system. So your application sees the iOS file system like a normal Unix file system. In fact, it is a normal Unix file system. Okay? It happens to be on a flash memory drive instead of a hard disk, but it's essentially a Unix file system. Remember, as we talked about before, iOS is all based on at the base operating system is Mach, which is a BSD variant of Unix. And so you can see the file system. There are file system calls that objects that you can go access to say, show me what's in the file system. And of course, there are protections in that file system, so you can't see everything. You don't have the right to read every particular directory, but it is basically a file system. However, when it comes to writing a file, you can only write in what's called your sandbox. Okay, this is a protected area that only your application can write in. So other apps can't write in it, and you can't write in other app spaces. This is just for you, okay, this sandbox. Why do they do this? Why do they make it so that apps can only write in the sandbox? Pretty obvious. Okay, security is one. You don't want some other application to be able to break your application by writing into your application's area somewhere you depend on. Privacy. You don't want some other app to be able to spy on what users of your app are doing by looking at the files in your space. And I'm an underrated one, which is cleanup. If the user deletes your app from their phone, they want everything having to do with that app to all go away. Okay? You don't want to have the Windows situation where they're digging through the registry, trying to get all the registry keys out and all that stuff. It's all completely contained in the sandbox, so you can completely delete your sandbox. Also, your sandbox, certain parts of it, get backed up when the person hooks up to iTunes. Okay? So documents that you might create, etc., get backed up. That way, if their phone got trashed and they restored it, they'd get the stuff back. So the sandbox is a really convenient way to group everything having to do with your application. So what's in this sandbox? Okay, so there's a bunch of directories in there. There's the application bundle directory. Okay, even on Mac OS, applications come in a directory, and inside there is your zip files, your language localizations if you have them, the binary executable or executables of your application. That subdirectory, very importantly, not writable by you. Okay, you cannot write into this directory, and I'm going to, the next slide, talk about what that means for you. However, there are lots of directories you can write into, like your documents directory. That's where you want to store permanent user data created by the user that you want to be permanent and backed up. It's exactly what it sounds like, the documents directory. Okay? There's also a caches directory. That's temporary data. So if you're writing a web browser app, this would be where all the browser cache would go, because you don't want this backed up to iTunes, right? You don't want the browser cache backed up. But it does stick around between application launches. So, you know, as long as it's not getting their app's not getting deleted, for example, it's staying around. You obviously wouldn't want your caches directory to start getting full with gigantic amounts of data, and you know, your app would get a reputation as being a disk space hog pretty quick if you did that. So you need to manage your caches, time them out, things like that. And there's a bunch of other directories in there. Check out the symbol NS search path directory in the documentation, and it'll give you a big long list of all the various directories you can find, and we're going to talk about the function that we use this in on the next slide. So back to this thing of what if you can't write into your own application bundle. What if you shipped some file, like a database, that you wanted the user then to be able to modify? How are you going to do that? And the answer is you have to copy it out of your application bundle into documents or wherever the appropriate directory is, and then you can modify it there. Does that make sense? You can't modify files inside your application bundle. Things that ship with your app are all read-only. So if you want to be able to write them, you have to copy them, read them out, and write them up to one of the writable places in your sandbox. All right, so how do we find out the paths to all these directories? The answer is there's this function, ns search path for directory in domains, and it takes an ns search path directory, which is an enumerated type, basically, of the directory you want. Like I want the caches directory, I want the documents directory, whatever. And that's why I say go look up that symbol if you want to find out what's in there. It takes this domain mask, which on the iOS is NS user domain mask. You know, on Mac OS, and the more complicated OSs, you might have multiple domains, network, file system domain, et cetera, but on iOS you don't. And then expand tilde is whether the little paths with the tilde in there get expanded out to be the actual user's home directory. We always say yes in iOS. Now, notice that this function returns an NS array of paths. So I might be saying, you know, NS search path for a directory in domains, the cache directory. Why would I get an array back? I'm only asking for one. Well, again, the answer is on a more complicated operating system, bigger system, you might have the local users cache directory, and then the local systems cache directory, and then the network's cache directory, etc. You might have, you know, different levels of cache directories. On iOS, you're almost always only going to get one directory back from this function. So we usually call the method in NSArray last object, which I talked about earlier in the course, which is a nice method because it returns nil if there's no objects in the array. Otherwise, it returns the last object in the array, which is better than saying array object at index 0, because that will crash if there's no objects in the array. You'd have to say if array count is greater than 0 and object at index 0 equal. This way, you just say last object, and you get the last object. So, you know, maybe this is bad programming style, but it reads really nicely to be able to just call this function, call last object, you get the thing. And at least the way things are now, you get reliably the directory you want. Okay? So what are some of the NS search path directory values? I told you go look them up, but there's the documents, caches. Also, there's some odd ones like NS auto-saved information directory. So this is information where it's auto-saving partially created, you know, you're working on a document on in your app, and you want to auto-save in case it crashes. And then when the user, if it does crash and the user comes back, it's like, oh, I want to get my auto-saved information. This is where it would be saved. You see what I mean? So there's a lot of odd ones like that. Okay, so how do you look into the file system? How do you do things like create directories, move files, copy them, rename them, etc.? You use this class called NS File Manager. Okay, so you'll need to do this for your next assignment. And I've just thrown, you create one with alloc init. There is a default manager that you could use as kind of a shared singleton. The only thing about that is it's not guaranteed to be thread safe to do that. So you're better off using alloc init. And that is thread safe. So in other words, if you created a file manager in one thread, we're going to talk about threads next week, don't worry. If you create a file manager in one thread and another file manager, a different alloc init one in another thread, they could both be operating on the same file system, and no bad things will happen, no exceptions or anything. You know, one of them will win when it comes to if they're working on the same file, but it'll be thread safe. So what can you do with File Manager? I just put up 3 random things here. You can create directory at path with intermediate directories and attributes. Okay, so that's a pretty complicated mechanism for creating deep directory hierarchies. You can just ask simple things like, is there a readable file at this path in the file system? And then you can also get an array of the contents of a directory. There's ways to enumerate the files in a directory using an enumerator. So this class, NS File Manager, probably has 50 methods. It also has a delegate, and the delegate is mostly a should delegate. So if you set this delegate, you could set the delegate for a file manager, give the file manager to someone else, and then control what that other API can do with the file system. Because you're going to get, as the delegate, you'll get messages like, should I open this file at this path? Okay, what should I do if there's an error when he tries to open this file? Should I continue or stop? You see what I'm saying? So it's a lot of should type of delegates. It's tons in there. You just got to read the documentation. I could spend 20 minutes on that. Okay, so NS string, surprisingly, is an important part of file management because it's got a lot of methods for managing file paths. Okay, like string by appending path component. That makes sure that you should not be building paths in iOS by saying this component slash, this component slash, this, okay, because that slash is kind of file system dependent separator of path components. Okay, now in Unix, yeah, it's /, but like in DOS, it's /. I don't think we're going to see iOS on DOS, but you never know what might be going on out there. So this is the methods you should be using, string object methods, to build paths. All right. You can also read and write strings from files with like string with content of file, etc. But it's mostly the path construction. There's probably a dozen path construction methods in a string that you definitely want to check out. Okay, so now I'm going to spend one slide on SQLite because I don't think any of you are going to be doing SQLite for your final projects. Probably never in your life are you using SQLite in an iPhone app because of core data, which I'm going to talk about in starting the next slide. But I'm just going to kind of mention it there because core data currently, by default, uses it as its backing store. So what is SQLite? Does everyone here, raise your hand if you know what SQL is. Okay, so everyone knows what SQL is, just a query language for a database, putting things in and out of a database, building tables, etc. So there is a version of SQL that comes with the iPhone, with the iOS, which is called SQLite. It manages the entire SQL database in a single file. It's a memory-based thing. It does do concurrency. It doesn't do it very well because it doesn't really need to, because you're not having multiple iOS processes accessing a single database, but you might have multiple threads in a single iOS application concurrently accessing things. So it does manage concurrency. Like I said, it doesn't do a great job of it. It's not highly efficient like a real SQL server would be. The API is, here's the salient pieces of it. You open a database, you execute SQL, you get back results through a callback mechanism, and then you close the database. That's pretty much how you do SQLite. There's some other API in there, but that's the basic mechanism. Okay? So if you're a SQL hacker, go crazy. All right, now, core data. So we're object-oriented programmers in this class, right? And we don't like C APIs like that SQL thing. That's a mess. Callback functions, you gotta be kidding me, no way. So we want to store complicated data, though, and do it in an object-oriented way. And so that's what core data is all about. And core data, very important system. Now, it might look on the face of it like a pretty complicated mechanism, and it is internally, but externally, the way you use it, especially if you keep the way you use it kind of simple, it can be very, very powerful. The other thing about core data, it can be abused. You can end up writing code that's very inefficient, that's basically pulling the entire SQL database into memory from their very start, and you might as well just be, putting it in arrays and dictionaries. But if you use it in a straightforward manner, and you think a little bit about what's going on in the database behind, it can be very efficient, actually, because it is SQL underneath. So what is core data? It's a way of creating an object graph meaning NS objects in your code, that's backed by a database. And I say usually SQL because you actually can have different persistent stores, but the one that's implemented with iOS is a SQL backing store. And so how does it work? How do you do it? And the answer is you use a graphical tool in Xcode. Okay, so it's another graphical tool to build a description of your objects and their attributes, or if you want to think in database terms, the tables and columns in the table, right? And then you query for objects using an object-oriented API. You create objects using an object-oriented API. And you could even use @ property notation to get the data in and out of the database. And by the time, hopefully we'll get to that today, we'll see how to do that even, okay? So imagine that there's these three worlds. There's the object-oriented world that you're in now, with all of these objects that you want to set properties on, get properties, etc. And then on the other side, there's the SQL world, all this obscure query language. It's like learning a whole other programming language. And then we're going to have a little spot in the middle that Xcode's going to help us manage graphically, which ties those together, okay? Which manages those two things so that we can work programming only here. We don't have to write any SQL, and yet we can still express pretty complicated database relationships. It's a pretty powerful system, actually. Okay, so how do we create this data mapping? Okay, this graphical thing in Xcode. And I'm going to show a demo of this on Thursday, so you're going to see it in a demo. But I'm putting it in the slides for reference, because you're going to see my demo, and then you'll be like, oh, how did he do that? So I'm going to walk through it here in slides so you remember how to do it. What you do is you start with new file. Okay, this data mapping is a file you're going to create, just like a zip file is a file you're going to create. And when you create the new file, you go to resource. In the left, you see how resource is selected. And when you look in there, you're going to see one of the options is data model. And that's what you're going to pick. Okay, so you're going to pick data model. Then it's going to ask you for a list of existing objects in your code that you want to turn into a data model. Okay? Now, usually we don't go this way. We don't usually start with all our objects created, and now we're creating a data mapping, so we can have a SQL database, we usually start in the middle. Well, we start with our data mapping and then build both sides. It builds the SQL side automatically for us, and we have it actually build our object side, stubs for it anyway, automatically as well. Okay, so we usually start in the middle. So usually here we just click Finish, which means skip this. Okay, we don't select anything. But you could go through here and pick some existing classes you have, and so that you could build a map for them, but we don't usually do it that way, and you won't be doing that in any assignments in this class. So you click Finish here, and you get to this data model file, and it's built into Xcode. It's not like Interface Builder where it runs a separate app. Okay, and so here we're seeing a view of the data model file. You can see on the left there, we're under Resources, and there's actually a directory there called XC Data Model D, D for directory, and our data model file is inside that directory. And the reason that it makes that directory and puts the file inside is because we can version this. You can imagine if you're writing an app and then you add a new feature that requires a new thing in the database, a new column, and you create a bigger mapping, you need to be able to support the old version because users will have created SQL databases through this mechanism that has the old attributes. Okay, maybe the attributes have changed or there's new ones or whatever. So it has a whole mechanism in here for versioning. Again, you won't need that in this class, but you should know that it's around. And that's why it puts it in directory there. So usually we drag our XC data model directory into Resources if it didn't create it there, because it is a resource. It's like a zip file. So that's usually where it wants to live. So if it creates it somewhere else for you because you had something else clicked and you did this new file, then think about dragging that in there. Okay, so let's kind of go through this API, or this UI rather, piece by piece and create some objects and some mappings and see what it looks like. So first we're going to create an entity, right? So the terminology is important to master here when you're doing core data. So an entity maps, remember that we're building a map. So in the mapping world, an entity maps to a table in SQL land or in database land and to an object or a class in our object-oriented land. Okay, so that's a pretty straightforward mapping. So here, for example, I've created an entity called photo. Okay, I do it by clicking on this little plus sign. There's a little plus sign there for creating entities. So you just click on that and it's going to create the entity. And then I'm going to change its name to be what I want. So I do that in the upper right corner there. You see where it says photo? So I just typed in the word photo and hit return. And it's showing the name in a lot of places. It's showing it in the entity list right there on the left. It's showing it graphically in this nice little graphical view in the bottom, which you're going to see get populated as we add more entities and attributes. And it's showing it obviously in the place where I can actually type it in and edit it. You might ask, what kind of object is this entity when it gets mapped into the code world? And the answer is, it's going to be an NS managed object. That's a new class. It's really kind of the core class in core data. All entities get mapped to an NS managed object or a subclass thereof. You can create your own custom subclass of NS managed object, and we're going to do that, so I'll show you that. But they start out when you first create an entity just being a raw NS managed object. Okay, so now the next thing I'm going to do, now that I have an entity, is I'm going to add an attribute to that entity. Okay, so an attribute maps in the SQL world, it's like a column in the table. And in the object world, it's a property, basically. It's like a property. And we're actually going to be able to use property notation to get at it. There's also ways to get at it without that, and I'll show you that as well. But you can think of it conceptually as it's a property. So the property I've added here is called thumbnail URL. Okay, and thumbnail URL is a property I'm going to use in my photo entity or an attribute I'm using my photo entity to store the URL out on the internet somewhere for a thumbnail of my photo. So this entity is a photo, represents a photograph, and so I want to be able to have a thumbnail of it. And so this is going to be a string that represents that. So how do I create an attribute? I click on this little plus, and actually when I click that plus, it's going to give me a little submenu right there that lets me create attributes and also relationships. And we'll talk about relationships in a moment too. But anyway, so I click that plus, and then I click attribute. And then it's going to create an attribute for me, and I set its name, same kind of way as I set the entity's name. And you can see it appears in all those places in its appropriate place. I'm calling this one thumbnail URL. Notice that the name I chose kind of has an Objective-C property looking feel to it in terms of its capitalization, right? Starts with a lowercase, all caps, U, R, and L. That's the way iOS says U, R, O, L. So I want to make sure I pick my attribute names so they look like Objective-C properties, because I'm going to be using them as Objective-C properties down the road here. You can see the type of this attribute is a string. Okay? String in the mapping world maps to whatever the SQL, how it represents a string. And in the object-oriented world, it obviously maps to an NS string. Okay? And we'll see some other types in a moment here. You can see there's some check. I'm not going to go over every single box and check mark throughout the UI, but some of the interesting ones I'll mention. There's this checkbox here, optional. That means that you can create one of these entities without specifying the value of this. In other words, it can be nil. Okay? I can have no thumbnail URL. I can still create a photo. Here's transient. Transient is kind of a weird property you're probably not going to use, but that's just a way to create properties that exist on the object side that have no backing store. And you might say, whoa, why would I ever want that? Well, because there's a lot going on the object side with these attributes in terms of notification when things change, stuff like that, that you want to take a benefit of some of that. Even if you're not actually storing the data, you might be deriving the data from other data or something like that. And then indexed means I might search on this. So that tells the SQL database you might want to build some big index or use some resources like memory resources to make searching quick. Okay, so if you know anything about databases, you know what this field is, creating indexes for certain items. You don't search on everything, so you don't want to build these big indexes for things you're not going to search on. All right, so there's that property. So let's add another attribute. So we had a thumbnail URL. I'm going to add a second attribute to my photo called thumbnail data. Okay, thumbnail data is going to be an attribute that stores the actual image data, the JPEG or whatever bits from my image. It's going to store that in the database. Now, is that a good idea? And the answer is, it's not really a bad idea. Okay, this SQL database can store pretty large amounts of data and pretty large chunks of data relatively efficiently. Would I want to store video in my SQL database? No. Would I want to store small sounds? Sure. Small images like thumbnails? Definitely. Larger images, like maybe my whole full-size Flickr image, maybe not. I'm kind of right on the border there of whether it makes sense, efficiency-wise, to store it in there. But the thumbnail, definitely I would. So let's look at this. So I click that same plus sign to create another attribute here. This one, its type is binary data, because that's what an image is, just a bunch of bits. And that will map to NS data in our object side. And so that's it. So that's that attribute. So now I'm going to add another entity. Okay? So this entity is a photographer. Right? So this represents an entity, an object, a table that is someone who took a photo, for example. Okay? And I do this the same way. I click on the add entity thing. Here's the entity's name. I'm calling it photographer. It's also an NS managed object for now. We can change its class later to be a subclass of NS object, but for now it's an NS object just like photo. And so now I have two entities, two attributes on one of my entities. So now let's add an attribute to this entity. And actually I'm not going to add an attribute. I'm going to be careful about the way I call this. I'm going to call it a relationship. Okay? So we're going to add a relationship between this object, this entity, which is a photographer, and the other entity, which is photo objects. Okay? So the way we do that, we click that little plus sign, same little plus sign we did to add an attribute, and here you can see the little submenu comes up. Instead of saying add attribute, I'm going to say add relationship. Okay? And when I do that, then I'll get this new relationship. Now I'm going to call this relationship photos, because this relationship is going to represent all the photos that this photographer has taken. Makes sense conceptually? And that's pretty straightforward. And so how do I specify the relationship between my photographer and photo objects? And the answer is with these buttons right here. You can see that there's this pop-up destination. That's the destination of the relationship. In other words, what this object has a relationship to. Obviously, in this case, the destination is going to be a photo. So if I were to click that pop-up right now, it would have only two things in it, photographer and photo, because those are the only entities I have. And then there's also inverse, which we're going to talk about in the next slide. So this relationship goes one way. See the arrow down at the bottom going over from photographer to photo? That represents this relationship. And notice that it's a too many relationship. It's a double arrow on the end of that line. What does that mean, too many? It means that a photographer can have taken multiple photos. So what's that going to look like on the object side when I have an attribute or a property, a relationship to be specific, that can be multiple things? Well, the answer is it's going to be an NS set. Okay, so that property type is going to be NS set star. And when you get it, you're going to get an NS set of NS managed objects, which are going to be photos. See, it's very straightforward. It's exactly what you would expect to happen. All right. So that's that. So now I'm going to add another relationship on photo that points back the other way to the photographer who took the photo. Okay? I'm going to call this thing who took. That's the name of my relationship. And I create it by going to the same place. I just go to destination up there and say photographer. And notice this time in the inverse, it doesn't say no inverse relationship. It says photos. So the inverse relationship is that relationship I created on the previous slide. And now look at the arrows down at the bottom, and it's not it's not a too many relationship, right? Each photo only has one photographer who took it. Every photographer has multiple photos, but each each photo only has one photographer. And so this relationship on the object side is not going to be an NS set. It's just going to be an NS managed object star. That's going to be the type of that property, because it's just going to be one object, which is going to be a photographer. So take a look down here at the bottom. You can see the arrow has now changed. It has arrows on both sides. It has double arrow on this side because it's a too many in this direction, and a single arrow on this side because it's a single relationship that way. Everyone cool with what's going on here? So relationships, very powerful mechanism, obviously, in your database for querying and building complex data structures, etc. You will definitely need to do this in your assignment. Okay, so that's it. Next, what do we have next? All right, so what else can you do with core data? There are tons of things you can do with core data: control faulting and all kinds of mechanism. But really, we're going to focus in this class on creating entities, attributes, and relationships like we just did in the last few slides, okay? And then working with those in our object-oriented world. Okay, that's what we're going to focus what we're going to do. Okay, so how do you access all this stuff in the code? We've created this nice mapping. We have these entities and attributes and relationships and all this stuff. How do I call any of this or do anything with any of these NS managed objects, create them, etc.? The answer is you need a magic thing called an NS managed object context. Okay? This is a magic object that manages all the querying and creating of objects in the SQL database using this mapping. Now, one thing I'll say about this object to be a little bit careful about, because next week your assignment is going to involve threading. NS managed object context and NS managed object are not thread safe. Okay? So you cannot be referring to the same NS managed object in two different threads. However, it is legal to have different NS managed object contexts working on the same backing store in different threads. That's where the concurrency of SQL comes in. Okay? Now, I say that just because when you're doing your assignments, you're only going to have one NS managed object context. It's going to be in your main thread. So when you do any database activity, please just do it in your main thread with your main thread's managed object context. Okay? It would be extra credit to go and try and build another NS managed object context that points to the same backing store and be updating things in another thread. However, that's not because it's not something you'd want to do in a real app. You might well want to do that because for performance reasons you might want to have another thread loading data into your database while the main thread is consuming that data. Do you see? So we're not going to do it in this class, but I just want to make sure you understand the threaded limitations of NS managed object context. Each managed object context will give out a different NS managed object for the same row in the table. Okay? And you might say, well, how do I communicate between threads about the same object? And the answer is NS managed objects have an ID that you can pass between threads and ask the context to create one for you. So that's how that works. Anyway, that's an aside about threads. Keep your stuff in the main thread in this class. All right, so how do I get an NS managed object context? And the answer is, when you create your project, you have to have the foresight to click the little button that says use core data for storage. All right, now if you've already created a project and you're like, oh, I want to start using core data now, my recommendation, create a new project and copy your code in, because it's really nice, the template code that gets created for you automatically here when you click that button, use core data for storage, when you create a project. It's only available when you first create a new project. So it creates a bunch of code in there for you for creating your persistent store and things like that. But the real key one method or property that it creates is this thing called manage object context in your application delegate. So your application delegate has a new property called manage object context. It returns an NS manage object context you're going to use to access all this magic. Okay? So that's key to know. All right, so now I have an NS managing object context. What can I do with it, or what do I want to do with it? Well, let's first talk about how can I create an object in the database, because that's a common thing you want to do, is create a photo or create a photographer in the database. And how do I do that? And the answer is you use this class called NSEntityDescription. Now, NSEntityDescription is the object in core data that's responsible, or the class that's responsible for managing the description of an entity. That's why it's called NSEntityDescription. In other words, it's responsible for being the conduit between core data and entities. Okay? So it has a class method called insertNewObject for entity for name. It's kind of a long name. And you just specify the name of an entity, photo or photographer. In our case, that's the only two entities we have. You specify manage object context, because that's the magic, and it will return you an NS managed object, which is a new photo. Make sense? This is very important to understand, because it's pretty straightforward, really. I told you that photos and photographers are all NS managed objects, and this just creates one for us, kind of a blank one. Right? No data in it yet. I'll have to set the properties, but it creates it. So I've told you all the objects that come back from the database are NS managed objects, because they either are an NS managed object or they inherit from it. You can't work otherwise. There's no way to get one back that's not. So that's why it says NS managed object star photo, as opposed to ID photo or anything else. Okay, so one thing to be careful about here. Passing the manage object context around. You're going to have a strong impulse when you do your homeworks to just get a hold of your application delegate and call managed object context, so that you have a managed object context when you need it to call this insert or to query. Okay? But you don't want to do that. Okay? Your application delegate is a global variable. Do not access it globally. Okay? Do not be importing the header files of your application delegate in your other classes. Also, don't be doing responds to self-managed object context to get around that. Okay? Pass the managed object context around. You're going to see that viewer view controllers, the ones that are getting table view data out of core data, are going to have inits that look a lot like init in managed context, and you're going to pass them the managed context they need to get the data. Okay? So the reason you want to do it this way, as your apps get more sophisticated, you might have multiple managed object contexts, for example, because of multi-threading. And so you want to be passing it around. You don't want to be always going back to this global data. That might well be the wrong thing. So, and just for good object-oriented, you don't want to go after global data anyway. Okay? So just a note for your homework. Okay, so I've created an object. I just did this insert object for entity for name. Now, how do I set its attribute values? How do I set the thumbnail URL? How do I set the thumbnail data on my photo object? And the answer is with these two methods in NSManageObject, value for key and set value for key. All right? The key is a string, which is the name of the attribute in your map, like thumbnail URL or thumbnail data or who took or photos. Those are all attributes and relationships in my mapping. I just say value for key and I'll get them back. The value is whatever's stored in the database or whatever you want to be stored in the database for that key. It'll be nil if nothing's been set yet and it's an optional, clicked optional type of attribute. Note that all values, based on this API on the top, are objects. So numbers, like floats and ints, and also booleans, are NS numbers. They come back as NS numbers. Okay? Too many relationships are NS set stars. That's what the value is. It's an NS set. Okay? Objects, like the who took relationship, which is just a pointer to one other object, are NS managed objects, or subclasses thereof. Okay? Binary data, NS data objects. So everyone got it? So that's it. So that's how you get your data. It's real simple. You just call these two methods, and it gets even simpler than that. But that's a pretty simple start. Everything under the covers will be managed for you. Faulting the objects in from the tables, lazily getting data when you make a big query, writing the data back out is all managed for you, except that writes happen to memory, and you have to make them go out to the database by calling save. Okay, there's a method in NS manage object context called save, takes an NS error star, and you need to call that to get all the changes that you made to attributes to actually go out to the SQL database. Okay, and this is just purely a performance thing. You know, the core data assumes correctly that you know better when you've done a batch of changes and it's ready to go out, versus it trying to figure out, should I write it now? Well, let's wait to see if a couple more attributes get set. You know, because it wants to be efficient about writing rows out and things like that. So when should you call save is what people ask the most. And the answer is anytime you make a batch of changes, when the batch is done, and a batch means a bunch of properties on one object or a few objects that get created together as a group. Once those are all done, hit save. Okay, save is not cheap because it's going to go out to disk, right, to write that out to the SQL database. But by the same token, if you don't do the save and your app crashes or the phone runs out of battery, it's lost. Okay, and you might leave yourself in some kind of odd, half situation if you save at the wrong times. So you want to save transactionally. If you know about databases, you kind of want to save under somewhat of a transaction. It's not like two-phase commit transactions here or anything, but you want to think of a group of changes that go together, hit save. Here's a little bit of code I put up here you can look at your leisure to deal with the error thing, because things can happen, real errors can happen when you're writing here, especially if you're doing concurrency. If you've got multiple threads writing, what if you save an attribute that some other thread just saved before you? Who wins? Right? And so there are rules in databases about using optimistic locking or other mechanisms to say who wins, and some of that comes back through as errors, like an error of I tried to write this and it was already there and the optimistic locking was on and I failed. So what do you want me to do? For your app, you probably can ignore the error. Okay? Just do your save. Maybe just print out the error if it happened. You're certainly not going to be looking in there trying to figure out what went wrong and do something in reaction to it. You might just log it like this code does. Okay, so calling value for key and set value for key, it's simple, it's straightforward, but it's kind of messy code. It doesn't really look very good because there's no static type checking of the types, like thumbnail data is an NS data. Where's that typed? Nowhere, because value for key just returns an ID. And you got a lot of these literal strings in your code, which are kind of like constants. It's kind of the whole thing's kind of messy. So what you really want to do is set and get these things with properties. And of course, we're going to show you how to make that possible. And the way to do it is you create a custom subclass of NS managed object for each of your entities. And that custom subclass will have an API, a public API, which is the properties, @sign properties, for all of your things. Now, it would be a pain in the neck if you had to write that code all the time and put the @sign property in the header file and figure out what goes on the implementation side and all that stuff. So not to worry, Xcode and core data will do that all for you. Okay, so let's talk a little bit how we can get Xcode to generate the code for a custom subclass to NS managed object for an entity. And there's really two ways to do it. One is you don't have a custom subclass yet, and you've got your map pretty much where you want it. Now you want to say, create my custom subclass, and it'll go and create it with all the properties in the header file and the proper implementation to go along with it. Okay? Another one is, I've already created that file, and now I've added a new attribute, or I changed something, and I want to go back and kind of edit my existing subclass, right? Add a new thing. So there's two ways to do it. Let's talk about both of those. That'll be the last thing we talk about today. So the way you do this is you go back to your data modeler window. Here you click on your data model, and you have to do this first. A lot of times people forget this, and they're like, it's broken, I can't do it. But you got to click on one of your entities. Doesn't really matter which one. And then you just click New File. Okay, because you're going to create a new class. It's this, normally when you create a new class, you say New File, and then you say, I want an NS object or UI view controller. Here, you say New File, and you're going to see this option, Managed Object Class, alongside the options you're used to. But that will only appear if you did the thing in the previous slide, which is to go select one of your entities. Again, it doesn't matter which entity you pick, because when you click this and then click Next, it's going to say, okay, that sounds good. Where do you want to put the files? So usually you can just say Next, put them in my project. And then it's going to ask you for all the entities, which one do you want custom subclasses for? And this is why I say it doesn't matter which one you pick, because at this point it's going to offer you the choice. And you can just click the little blue select box right there to pick what you want. So here I've picked only photo. And these things at the bottom, you're going to want to leave those checked, because you want to want Objective-C 2.0 at-sign property notation, etc. for these. So you do that, and you can see it created photo.m&h. You see them right there for me, for my entity. And you probably are going to want to move that up to your classes folder, because you're probably not going to want it inside your XE data model D directory, which is where it's going to put them. And so now you've got, so that's a way to get started. Now, what's in those files? We're going to talk about that next time, so don't worry about that too much. But what about the other way I said, where I've already got these files created, and I want to add the stuff to it? And the answer is you use a paradigm basically like copy and paste. You go into your modeler, you select the thing, the attributes that you want to bring over to your custom subclass, and then you do a special copy. You don't use normal copy, use a special one. So let's see what that looks like. So here I've got a slide which is a whole screen shot, and you can see that I've selected 3 attributes there. See, thumbnail, data, thumbnail URL, and who took. And then I've gone up to the design menu in Xcode, down to data model and over, and I've said copy Objective-C 2.0 method declarations to clipboard. So this is the special copy. And then I just go over to my photo.h, go to wherever I want it, hit paste, and it'll put them in there. Okay? And if I'm changing something that's already there, I would delete the old stuff that was wrong, paste in the new stuff. So it's just copy and paste, basically, is the way it works. And you see there's 2 different copies, one for your header file and one for your implementation file. Okay? So that's how you do it. I'm going to stop here. Next time, I'm going to start with what does the code that you're copying and pasting here look like? It's actually incredibly simple, because a lot of what the work that's going on is in NS Managed Object. And then we're going to talk a little bit about then we'll go talk about querying, because now I've got all these objects, set their attributes. Now I want to query on them, search for objects, right, that have certain attributes. So I'm going to do that. And then we'll talk about how do I hook all that up to a table view. Because you can imagine if you had this nice big tables of photos and photographers, you'd want to do nice, really easy table view queries, and you can. I mean, you can do table views, whole table views that do special searches on photos and photographers in, 6, 7 lines of code, and it does all the magic for you. All those table view methods, it can implement all those for you. Okay, so we're going to talk about that, and then I'll have a demo after that next time that shows all this. Okay, sorry to keep you a little long, and I will see you on Thursday.
For more, please visit us at stanford.edu.